If the Gree inverter mini-split air conditioner is showing an HC error on the display, in this video, I will explain what it means and how to fix it. The company has named this error code as PFC, or PFC protection. PFC stands for power factor correction. So let me explain to you what power factor correction PFC is. I will divide this video into two parts. In the first part, I will explain what power factor correction is. In the second part, I will go over what components you need to check on the circuit board and which parts need to be replaced to fix this error. So let's begin by explaining power factor correction using a graph. I'll draw a graph to explain this. AC electricity produces sinusoidal waves that look something like this. Half of the cycle moves upward and the other half moves downward. This wave continues in this pattern, and its frequency is typically between 50 to 60 Hz, which varies in different countries. Now, if the voltages are correct in the system, but current is also flowing with the electricity, the currents graph would look something like this. On the downward wave, it would also have a similar pattern, and this pattern would continue. To correct this current pattern and its waveform, a circuit is installed on the outdoor circuit board for power factor correction. This circuit helps reduce these spikes as much as possible. So, how should the current waves appear in the circuit? When there are no current spikes, the current waveform will look similar to the voltage waveform. Now friends, I'll explain what to test on the circuit board when the PFC protection error shows up. The circuit board in front of us is for a 1.5-ton Gree outdoor unit. First, you should definitely check the main supply to ensure the voltages are correct and stable without any fluctuations. If there's a problem with the voltages, you need to fix it. Next, you should remove the two line filters from the circuit board and check them with a multimeter. The resistance value should be between 1 to 4 ohms. If the resistance exceeds this range, it indicates that the line filter's resistance has started to increase, which could mean it's faulty. Before these line filters, there is a small capacitor installed. If there's any fluctuation or issue with this capacitor, it can also cause problems. So you should remove this capacitor from the circuit board and check it as well. When electricity passes through this line filter, it helps filter and purify the AC electricity. After that, the system passes this electricity to the rectification circuit. The rectifier also needs to be checked because if there's any fluctuation, voltage spikes, or any damage, it can cause problems. The rectifier's job is to convert AC voltages into DC voltages. If the rectifier is working correctly, the supply then passes through these two wires. These two wires are connected to a reactor. Here, another important component comes into play: 3 large capacitors. These capacitors boost the electricity, meaning they boost the voltages. The input voltages coming to the inner pin of the rectifier are AC 220 volts, and the two outer pins of the rectifier are connected to these capacitors. On these capacitors, there should be 320 volts on standby and 380 volts under working conditions. If you're getting these voltages, that's good. These two wires are connected to the reactor, and this is the reactor where these wires are attached. The purpose of this reactor is to purify the current. Therefore, we need to check this reactor as well. I've already made a video on this reactor, which will be linked at the end of this video. If the reactor is faulty, replace it, and your system may be fixed. Additionally, if any of these 3 capacitors are faulty, you might still see correct voltages. However, if there's a short circuit or any issue with these capacitors, it can still cause problems. You should remove these capacitors from the system and thoroughly check them. If their capacitance value has weakened, replace them to eliminate spikes and fluctuations in the system to make the system work normally. Now, if despite all this, the issue still isn't resolved, you'll need to check the voltages between the wires of these reactors and the IPM Intelligent Power Module. I'll explain how to do that. First, take a multimeter and set it to diode mode. Connect the probe wire to one of the reactor wires. Now, attach the black probe to the positive pin of the IPM. The multimeter should show a voltage drop of around 0.416 volts, indicating that everything is working correctly. Next, attach the black probe to the negative pins. You should see some voltage readings appear and then disappear, which means this point is also working fine with no issues. Now, switch the red probe and attach it to the other wire. There should be no voltage drop on either the negative or positive pin. Then, reverse the positions of the probes. Attach the red probe to the positive pin. Again, there should be no voltage drop. On the negative pins, you should get a reading of 0.976 volts. If you see this voltage on the negative pin, that means everything is functioning correctly. This voltage drop indicates the connection between the diode and the IGBT, insulated gate bipolar transistor. Now connect the black probe to the other wire and check it again with the IPM. This time, there should be no value showing on the multimeter, indicating that the system is perfectly fine and working correctly. However, if you get a 0 reading, it means either the IGBT or the diode is short-circuited in the system. In that case, you'll need to check both components to fix the HC error in the AC. Click on the left or right thumbnail to watch our next videos and subscribe. Thank you.